So after finding the velocity and denoting this by c1, how do I continue to find the distance? So I keep 1/3 outside, and I have t to the third, which is t to the fourth over 4, minus 2, t to the third over 3, plus 6, t squared over 2, plus c1t plus c2. And now we have two conditions. Those two conditions will help us determine c1 and c2. Okay, so let's start with the first condition. S of 0 is 0. I can rearrange the function a little bit, but what does S of 0 equals 0 give us?
C2.
Yes. How much is C2?
0.
That's it. Thank you very much. So minus 2/3 t cubed plus 3 t squared plus c1t. And we have a different condition now, that is S of 1 equals 20. Okay, so 1 divided by 12 minus 2 divided by 3 plus 3 plus c1 equals 20. Lovely. I'm going to multiply by 12 everything. After or before, it doesn't matter. Okay, so I have 1 minus 8 plus 36 plus 12 c1 equals 240. So 12 c1 is 240. What do I have on this side? 240. This is 37, right? 37 minus 8 minus 29. So c1 equals, what is this? So it's 211, I think, divided by 12. Correct my numbers. So S of t equals 1 over 12 t to the fourth minus 2/3 t to the third plus 3 t squared plus 211 over 12 t. Are my numbers correct? I'm checking. So this is correct. That's correct. That's correct. That's correct. That's correct. That's 37. Minus 8 is minus 29. And I think that 11 plus 29 is 40. Yes, divided by 12. Okay. So this is the motion function given the acceleration. Any questions? About how this works? Going back to find a function whose derivative is given to us. It could be the first, it could be the second derivative. We are still able to determine the most general antiderivative or the one that fulfills the given conditions. Any questions? I think I'm on 9, isn't it? Yes. Any questions? Okay, I'm starting chapter 5, but I'm not going to even put the title because there is a long way till the title, really. So first I would like to talk about the summation. Notation. So we have different ways of presenting a sum of numbers. For example, let's suppose I want to add 1 to 2 to 3 to ... 100. I don't really want to write this notation. It's too long. I have to write the first 2 or 3, then I have to put plus, then I have to put exactly 3 dots. Mathematically, that's the correct order and sequence, and plus, and the last one. Instead, we will use a letter that is a Greek letter that's the same with S, but it's a Greek letter because of the shape of the letter. This shape, it's still a sum, of terms, but the shape allows us to better write an index. So this is the index of the summation notation, or the sigma notation. So this is called sigma notation, or summation notation, same thing. So this is the index. The index has a lower limit. This has nothing to do with the operator lim. So this is the lower limit of the index, or the summation notation, till 100, because that's where I have to stop. So this is the upper limit of this sum, and what I will put here is just simply I. We have so many different situations that I'll show in a minute, but how come that this is the same with this? It is. When I is 1, the sum says plus. When I is 2, plus. The sum, plus. When I is 3, plus, dot, 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 and I get to the last one, the sum is 100. The last one is 100. For example, another situation will be, how do I present this? Let's say 5 to I plus 3I squared. Let's say this time from I equals 0 to 4. What does this mean? This is again a generic term, generic or general term if you want. And how will I expand? I'm going backwards now. I want to understand what this means. Very simple. When I is 0, 5 raised to 0 plus 3 times 0 squared, that's the first term, plus, because the sum says plus. 5 raised to 1 plus 3 times 1 squared, plus. 5 raised to 2 plus 3 times 2 squared, plus. 5 raised to 3 plus 3 times 3 squared, plus the last one, 5 raised to the 4th power plus 3 times 4 to the 2nd power. And of course, I can calculate and determine the number. Notice that the moment we create a notation or we come up with something, properties follow. So there are two properties here of the sigma notation. One property is, if we have the sum like I presented it here, from two generic terms, let's say AI plus BI, from I equals 1 through n, I can separate into two sums, the sum of AI plus the sum of BI. Of course, both from I equals 1 through n, the same thing. No, I'm not distributing. It looks like I'm distributing the sigma notation to both, but I'm not. That's not the issue here. That's not what I'm trying to explain. I'm trying to say that the sum of two general terms is the sum of the first one plus the sum of the second one. It will not make any difference if we have subtraction here. It will still be the same idea. So that's one property. One other property, I need these for chapter 5. That's why we're discussing all these. So another property, I think we're on 10, yes. So another property, property number 2, is the sum of a constant times AI, where AI is the general term, from I equals 1 through n. Like with the limits, like with everything else, the constant goes in front. So the sigma notation is used when we are adding terms. That's number 1. And it has two properties. The sum of a sum or difference of general terms is the sum or difference of those. And if there is a constant multiplied by a general term, the constant goes in front. We had the same thing with limits, if you remember. We had the limit of f of x plus g of x. If both limits exist when x approaches a, we had the limit of f of x plus the limit of g of x. Same property. A and x approaches A. And if we had a limit of a constant times a function, we had the same property. We had the constant in front, limit of f of x as x approaches A. Okay, so this is fine. We learned about this new notation, sigma, or summation notation. We learned about the properties. There are 4 identities that we will be using in chapter 5. 1, 2, 3, and 4. The first one is the easiest one. The sum from I equals 1 through n of 1. 1 plus 1 plus 1 plus 1 plus 1 plus 1 n times is what? What do you think? Wild guess. Let's look at a simple example. The sum of 1 from I equals 1 to 3. I have 1 when I is 1 plus when I is 2 plus when I is 3. What do I get? Good. So then what is the answer? That's it. Perfect. Okay. The other 3, we can prove them if you would like to prove them using mathematical induction. But we do this in pre-calculus. The sum of I, when I goes from 1 through n, the formula is, and you have to have these for the next test, for test 4, n plus 1 divided by 2. I'm going to jump to the last one because it's related to this, and you should remember them together, because the third one is the most difficult one to remember. It's not a big deal, but I equals 1 through n, from I to the 3rd power is the same thing, but squared. This one is a little bit more involving. So this is the sum of I squared from I equals 1 through n. This is n plus 1, 2n plus 1 divided by 6. So this is the only one that is different than, it has 3 factors and 6 in the denominator. But these 2 are identical, sort of, right? Just the I to the 3rd has power 2. I is just n plus 1 over 2. And this is obvious. So let me know if you want to prove any of the other 2, 3, or 4. It's a big theory behind it. It's the mathematical induction theory. If not, then we will have to remember these or have them handy for from this moment till we finish the semester. So these are the 4 identities, and they all involve the summation notation. Notice one thing. So these are all polynomials. It's like x and x squared and x cubed. I don't have for you a sum of, let's say, 4x to the 4th, or just power 4, or any other power. I only have power 1. We only have these 4 identities: power 1, power 2, and power 3. Nothing else. We don't have other options here. So if you ask me, find the sum of tangent squared x from x or I, let's see, keep it with the index. I equals 2 to 10, I'm not going to be able to give you that answer. I have to determine it one by one and add them up. I don't have a formula. So, and you'll see in a minute how we use this. But, for example, if you ask me now, find the sum from I equals 1 to 100 of I don't have to put it anywhere. I know it's n plus 1 divided by 2, which means 100 times 101 divided by 2. I simplify, and I get 5050 and done. If you ask me find the sum from I equals 1, notice that it has to start at 1, but you can ask me find the sum from I equals 4 to 50 from I, there will be no problem. I will find the sum from I equals 1 through 50 of I and subtract the sum from 1, I equals 1 through 4 of I, and I will still be able to give you that answer correctly. But all our identities, careful, all identities start at 1 with an index with 1. Now you will find the index of the summation notation is I, sometimes J, sometimes K. It can be anything, but these are the most used, I, J, K.